You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your educational journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. A product vision is a concise and motivating statement that articulates the future state an organization seeks to achieve through its product or service. It is not a detailed plan, but rather a guiding star, helping teams understand the why behind their work. A strong vision clarifies boundaries, shaping what will be pursued and what will not, and it provides a framework for investment decisions. For example, a product vision for a healthcare app might be to empower patients to manage chronic conditions with confidence and ease. This narrative links the problem space complex health management to intended, impacts empowered users and improved outcomes. The vision creates alignment among stakeholders and teams, ensuring that daily backlog items connect back to long-term purpose. On the exam, product vision scenarios often ask candidates to recognize its role in guiding choices about priorities and trade-offs. Understanding outcomes versus outputs is crucial in agile delivery. Outputs refer to tangible deliverables such as features or reports, while outcomes represent the actual results or benefits realized by customers and the business. For instance, releasing a new dashboard is an output, but reducing decision-making time for managers is the outcome. Focusing on outcomes prevents teams from chasing feature counts without regard for value. It also helps guide trade-offs when capacity, risk, or timing constraints emerge. If only some items can be delivered, teams should prioritize those most likely to create meaningful outcomes. On the exam, candidates may face questions where outputs and outcomes are conflated, and the correct answer will emphasize results over raw delivery. Agile emphasizes that success is measured not by what is built, but by the value that work creates in the real world. Personas and user roles provide a human anchor for product decisions. Personas are archetypes built from research, representing common patterns of needs, behaviors, and constraints in a target audience. For example, Emily, a time-pressed manager, might represent users who value quick insights and mobile accessibility. User roles, in contrast, describe functional categories such as administrator, customer, or analyst. Both serve to ground discussions in reality, preventing teams from designing in the abstract. By referring to personas and roles during refinement, teams can ask, "Does this story meet Emily's needs?" or "How will the analyst interact with this feature?" On the exam, persona-related scenarios often highlight the danger of ignoring user perspectives. Correct answers usually involve anchoring backlog refinement or acceptance criteria in evidence-based archetypes, ensuring solutions address real-world contexts rather than assumptions. Jobs to be done is a framework for articulating user needs in terms of the goals they are trying to achieve, independent of specific solutions. Instead of asking what features users want, the focus shifts to what job they are hiring the product to do. For example, a commuter may not want a rideshare app per se, but rather a reliable, affordable way to get to work on time. Framing needs this way reduces solution bias and clarifies success criteria. It helps teams avoid over-engineering features and instead focus on delivering what users actually value. In backlog refinement, jobs to be done supports clearer problem statements and more targeted acceptance conditions. On the exam, scenarios may test candidates' ability to recognize when to step back from feature wish lists and instead clarify the underlying job. Agile delivery thrives when teams focus on jobs rather than outputs. Value hypotheses and assumptions are the explicit beliefs teams hold about why a feature matters and what must be true for it to succeed. A value hypothesis might state that, quote, adding in-app notifications will increase daily active usage by 15%. The assumptions include that users check notifications regularly and that they perceive value in the reminders. These beliefs guide experiments and thin-slice deliveries, allowing teams to validate or invalidate assumptions early. When value hypotheses are left implicit, teams risk building features that create little impact. Making them explicit fosters alignment, accountability, and evidence-driven prioritization. On the exam, candidates may encounter scenarios where assumptions remain untested, leading to waste. The correct agile response typically involves surfacing hypotheses and testing them before committing significant investment, embodying empiricism and risk reduction. User stories provide a lightweight structure for capturing requirements, balancing simplicity with context. A common grammar is, as a user role, I want capability so that benefit. This format ensures clarity on who needs something, what they need, and why it matters. For instance, as a customer, I want to reset my password online so that I can regain account access quickly. Stories are not meant to be complete specifications. They serve as placeholders for conversations that clarify details. Acceptance criteria complete the story by defining confirmation. On the exam, user stories often appear in questions about requirements practices. Candidates should recognize that stories are not rigid documentation but conversation starters that promote shared understanding and adaptability. Agile values dialogue and collaboration over exhaustive upfront documentation, and user stories embody this principle. The INVEST model offers a heuristic for evaluating whether a user story is ready for development. Stories should be independent, negotiable, valuable, estimable, small, and testable. Independence reduces coupling so that stories can flow through the backlog flexibly. Negotiability reminds teams that stories are not contracts, but conversation points. Value ensures that each story contributes to outcomes. Estimability allows planning. Small keeps cycle time short, and testable guarantees verifiable completion. For example, a story that is too large to estimate violates the S in INVEST and should be split. On the exam, candidates may be asked to identify which story is ready for inclusion in a sprint. Recognizing INVEST qualities allows them to select the option that aligns with flow-friendly, value-focused backlog practices, reinforcing Agile's emphasis on delivering increments consistently. Acceptance criteria are the specific, verifiable conditions that determine whether a story is complete. They reduce ambiguity, bound scope, and support test design. For example, acceptance criteria for a login feature might include user is locked out after 3 failed attempts, or passwords must meet complexity requirements. These criteria align the team, product owner, and stakeholders on what success looks like. They also enable consistent, done decisions across team members, ensuring that quality is not subjective. Without clear acceptance criteria, teams risk misinterpretation and rework. On the exam, scenarios often include vague requirements that lead to disagreement about completion. The Agile answer usually involves clarifying or defining acceptance criteria before starting work, demonstrating that clarity up front prevents waste and promotes flow. The hierarchy of epics, features, and stories provides a structure for managing scope without losing intent. Epics represent broad capabilities, features break those down into deliverable chunks, and stories represent implementable slices. For instance, improve customer onboarding might be an epic, create guided tutorials a feature, and as a user, I want a walkthrough for setting preferences, a story. This hierarchy ensures coherence between strategy and execution. It allows decomposition from large visions into actionable work while preserving alignment with outcomes. On the exam, candidates may face questions about how to manage scope at different levels. The correct answers usually emphasize decomposition into smaller, testable pieces while maintaining connection to higher-level objectives. Agile's strength lies in linking vision to increments, and this hierarchy makes that possible. Story-splitting strategies help teams decompose large stories into smaller, vertical slices that can deliver value earlier. Techniques include splitting by workflow step, data type, business rule, or user interface variation. For example, instead of building a full reporting suite at once, a team might first deliver reports for a single dataset. Vertical slicing ensures that each story represents a usable increment rather than a partial component. It reduces cycle time variability, avoids hidden coupling, and validates assumptions sooner. On the exam, splitting often appears in scenarios where large stories threaten flow. The correct response usually involves splitting into smaller, independent increments that preserve value. Candidates should recognize that agile delivery favors learning and feedback over batch size, making story splitting a practical tool for sustaining momentum. The definition of ready, or DOR, acts as an entry agreement that specifies conditions a backlog item must meet before the team commits to it. It reduces thrash by ensuring that essential information, dependencies, and risks are addressed in advance. For example, a story may require clarified acceptance criteria, dependency resolution, and an estimate before it is considered ready. DOR is not meant to be rigid, but rather a safeguard against waste. On the exam, readiness often appears in questions about whether a team should accept unclear or incomplete items into a sprint. The agile answer typically emphasizes that DOR helps prevent rework and frustration by clarifying expectations before work begins, aligning with agile's principle of sustainable flow. The definition of done, or DOD, is the exit agreement that encodes quality, compliance, and integration expectations. It ensures that increments are potentially releasable and meet consistent standards. For example, a DOD might include code review completed, automated tests passed, documentation updated, and integration into the main branch. Without a DOD, done becomes subjective, leading to uneven quality and unpredictable delivery. A clear DOD creates trust with stakeholders and consistency across teams. On the exam, candidates may encounter scenarios where incomplete or untested work is presented as finished. The correct response usually emphasizes the importance of adhering to the DOD to maintain reliability and value. The DOD embodies Agile's commitment to quality, reinforcing that value delivery requires both functionality and integrity. Spikes and prototypes are short, bounded activities designed to reduce uncertainty. A spike might involve exploring a new technology or researching integration options, while a prototype tests design ideas quickly. Neither is intended for production, but both provide valuable learning. By constraining scope and time, spikes and prototypes de-risk decisions without committing to full-scale development. For example, a team might run a 2-day spike to evaluate whether a third-party API supports required functionality. On the exam, candidates may face questions about how to handle uncertainty in scope or technology. The agile answer usually involves using a spike or prototype to generate knowledge rather than pushing uncertain work into delivery. These practices reflect Agile's emphasis on empiricism and learning. Non-functional requirements, or NFRs, describe quality attributes that apply across increments, such as performance, security, usability, or maintainability. Unlike functional requirements, which describe what a system does, NFRs describe how well it must do it. For instance, a login system must authenticate users within 2 seconds, not merely authenticate them. Ignoring NFR's risks, delivering features that functionally work but fail to meet stakeholder expectations. Agile teams incorporate NFRs into acceptance criteria and DOD, ensuring they are not deferred or overlooked. On the exam, candidates may encounter scenarios where features technically work but lack usability or performance. Correct answers usually emphasize integrating NFRs into regular work, treating them as essential rather than optional. NFRs ensure that increments are not only functional but also reliable and sustainable in real-world contexts. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. A product roadmap provides a forward-looking sequence of problem themes and learning milestones, offering a directional view of where the product is headed. Unlike rigid project plans, a roadmap is outcome-oriented, showing how customer value will be explored and delivered over time without overcommitting to fixed dates. For example, instead of promising release feature X in June, a roadmap might state, deliver improved onboarding to reduce churn in Q2. This framing emphasizes outcomes and flexibility, helping stakeholders understand priorities while preserving adaptability. On the exam, roadmaps often appear in scenarios where stakeholders demand certainty. The Agile answer typically emphasizes intent and outcomes over date-driven promises, reflecting the principle that discovery and learning shape delivery paths. Roadmaps are guiding artifacts, not guarantees, and they anchor vision while leaving space for empirical adjustment. Release planning takes the abstract intent of the roadmap and translates it into coordinated increments. The focus is on grouping increments into meaningful deliveries that balance risk, capacity, and readiness. For instance, a release plan may coordinate 3 sprints of work into a package aligned with compliance milestones or marketing events. Release planning does not fix every detail but offers a shared view of what can be delivered and when, while recognizing that adjustments may occur. On the exam, release planning often appears in questions about balancing stakeholder expectations with agile flexibility. The correct answers usually highlight planning as collaborative and adaptive rather than deterministic. Release planning reinforces that value is delivered incrementally, and coordination ensures that these increments accumulate into coherent outcomes that matter to the business and customer alike. An increment is the tangible result of completed work that is integrated, tested, and potentially releasable. It represents value delivered and evidence to guide the next decision. Each increment should be usable, whether or not it is released externally. For example, a team may complete a reporting feature that is ready to deploy, even if stakeholders choose to delay release. Increments provide transparency and allow inspection, ensuring that progress is visible and empirical. On the exam, increments often appear in scenarios about demonstrating value or measuring readiness. The correct Agile response typically emphasizes delivering increments frequently to reduce risk and accelerate feedback. Increments embody Agile's core promise, delivering working outcomes early and often, building trust with stakeholders, and enabling continuous alignment with goals. Iterations, or sprints in Scrum terminology, provide the fixed time box in which increments are created. Each iteration follows a rhythm of planning, doing, inspecting, and adapting. This cadence establishes predictability while allowing frequent engagement with stakeholders. Iterations create opportunities for learning, enabling teams to refine not only the product but also their processes. For example, a 2-week sprint might deliver a working increment, review it with stakeholders, and identify improvements for the next cycle. On the exam, iterations often appear in questions about managing scope, planning, or stakeholder engagement. Candidates should recognize that iterations are about creating regular inspection points rather than maximizing throughput in a single cycle. The time box drives discipline, ensuring that value is delivered steadily rather than deferred indefinitely. Continuous integration and continuous delivery, often abbreviated as CI/CD, represent automation practices that sustain flow and reduce risk. Continuous integration means merging code frequently and testing it automatically, catching defects early. Continuous delivery extends this by keeping the product in a deployable state at all times, enabling rapid release when desired. Together, these practices shorten feedback loops, improve quality, and reduce the cost of change. For example, a team using CI/CD can release features confidently within hours, rather than waiting weeks for manual testing and integration. On the exam, CI/CD often appears in questions about reducing risk, accelerating feedback, or ensuring readiness. The correct answers usually emphasize automation and integration as enablers of agile flow, reflecting that agility is sustained by both process and technical practices. Refactoring is the disciplined restructuring of code or artifacts to improve design and maintainability without altering behavior. It prevents technical debt from growing unchecked and supports long-term adaptability. For instance, a team might refactor duplicated logic into a single reusable component, making future changes easier and less error-prone. Refactoring should be small, continuous, and integrated into normal work, rather than postponed indefinitely. On the exam, refactoring appears in scenarios about quality or debt management. The agile response usually involves addressing refactoring as part of ongoing work, rather than delaying it until problems become acute. Refactoring reflects Agile's emphasis on sustainable pace and continuous improvement, ensuring that increments remain robust and adaptable in the face of evolving requirements. Technical debt represents the hidden cost of expedient choices that prioritize speed over quality. While sometimes intentional, such as delivering a quick solution to meet a deadline, debt accumulates interest. Future changes become slower, riskier, and more expensive. Making technical debt visible allows teams and stakeholders to make informed trade-offs about when to invest in repayment. For example, a team might log known shortcuts as backlog items and prioritize repayment alongside new features. On the exam, technical debt appears in scenarios where teams must balance immediate delivery with long-term sustainability. The agile answer usually involves acknowledging debt explicitly and managing it transparently, rather than ignoring or indefinitely deferring it. Agile recognizes that debt is sometimes necessary but must be tracked, prioritized, and repaid to maintain flow. Feature toggles, or feature flags, are techniques that allow functionality to be deployed but hidden or activated selectively. They decouple deployment from release, enabling safe experimentation and fast rollback. For instance, a team may deploy a new search function behind a toggle, exposing it only to a small group of users. If issues arise, the toggle can be switched off without rolling back the entire deployment. Feature toggles reduce risk, support incremental delivery, and allow data-driven validation of hypotheses. On the exam, candidates may face scenarios about reducing release risk or enabling experimentation. The agile answer typically involves using toggles as a lightweight way to validate learning while protecting production stability. This technique embodies agility by enabling flexibility and responsiveness in delivery. Enabler work refers to backlog items that support delivery but do not directly create user-facing features. Examples include building infrastructure, upgrading tools, or establishing architecture. Though often invisible to stakeholders, enablers reduce friction, protect flow, and create the foundation for sustainable value delivery. For instance, setting up automated test frameworks may not excite customers, but significantly improves quality and throughput. On the exam, enabler work often appears in scenarios where stakeholders push only for features. The correct agile response usually involves explaining why enablers are essential and ensuring they are prioritized alongside features. By recognizing enabler work as integral, candidates show an understanding of how technical and business perspectives must be balanced to achieve true agility. Environments and promotion paths describe the sequence that work travels from development through testing and staging into production. Each stage includes controls to preserve traceability and confidence. For example, a feature may pass through unit tests in development, integration tests in staging, and performance checks before promotion to production. Promotion paths ensure that increments are stable, compliant, and verifiable at every step. On the exam, candidates may encounter scenarios about managing flow across environments or ensuring quality before release. Correct answers usually emphasize lightweight but reliable promotion practices that balance speed with assurance. Agile favors minimizing unnecessary gates but also recognizes that controls are necessary for sustainable delivery. Environments provide the scaffolding that allows rapid iteration while protecting reliability. Change management in agile delivery emphasizes lightweight governance that preserves safety and compliance without undermining responsiveness. Traditional change processes may require lengthy approvals, but agile teams seek faster mechanisms aligned with iteration cadence. For example, predefined guardrails or automated approval workflows allow routine changes to flow smoothly while still meeting compliance needs. On the exam, change management scenarios often involve balancing governance with agility. Correct answers usually emphasize proportionality. High-risk changes may require formal review, while low-risk ones proceed within team authority. This reflects Agile's belief that governance should protect value rather than obstruct it, ensuring compliance while sustaining throughput and adaptability. Handoffs and dependencies are common sources of delay and defects. Each time work moves between teams or depends on another group, the risk of misalignment increases. Agile teams minimize these risks by cross-skilling, clarifying interfaces, and reducing batch sizes. For example, rather than passing requirements from analysts to developers to testers sequentially, Agile teams collaborate continuously to reduce handoffs. Dependencies may still exist, but transparency and coordination mitigate their impact. On the exam, scenarios about bottlenecks or delays often involve hidden handoffs. The correct responses usually emphasize reducing or managing dependencies rather than tolerating them. Agile thrives on flow, and minimizing handoffs is one of the most effective ways to improve predictability and quality. Alignment between ready and done serves as a guardrail that ensures entry and exit criteria match team capability, toolchain realities, and stakeholder expectations. Ready prevents work from starting prematurely, while done ensures it finishes completely. Misalignment creates waste. Stories accepted as ready but not meeting the DoD lead to incomplete or defective increments. For example, a team might accept a story without clarified acceptance criteria, only to discover late that it cannot be considered done. On the exam, candidates may face scenarios where teams struggle with unclear criteria. The Agile answer usually involves clarifying or aligning ready and done to restore flow and consistency. This alignment reinforces Agile's focus on quality and transparency across the lifecycle of work. Operational readiness ensures that increments are not only delivered, but also supported once in production. This includes monitoring, recovery, and support practices that sustain value beyond release. For example, deploying a new feature without monitoring exposes stakeholders to risk if issues go undetected. Agile teams build operational readiness into their definition of done, confirming that delivery includes supportability. On the exam, operational readiness often appears in scenarios where delivery is treated as complete, but sustainability is neglected. The correct response usually emphasizes preparing for life after release, reflecting Agile's holistic view of value. Value does not end at deployment. It continues through ongoing stability and support that protect customer trust. In summary, the vocabulary of product and delivery provides teams with a shared language to translate strategy into increments of customer value. Roadmaps and release planning frame intent, increments and iterations sustain cadence, and practices like CI/CD, refactoring, and feature toggles maintain flow and quality. Technical debt, enabler work, and operational readiness remind teams that sustainability is as important as speed. By mastering these terms, candidates equip themselves to reason effectively about scenarios where product and delivery challenges intersect. Shared definitions reduce miscommunication, align stakeholders, and ensure consistent application of Agile principles. This lexicon empowers teams to balance discovery with execution, building products that are not only delivered efficiently, but also aligned with outcomes that matter. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.